Hello, everyone. Today we have with us Bentzi, who was working with bibliometrics package, and he now did some analysis using text mining, so which can be considered as an addition to the bibliometric analysis. So now we are going to see how he did it, and possibly in near future analysis, you will be able to add some additional analysis using text mining in R. So the floor is yours, Benji.
Okay, thank you. Thank you so much, Monim. So yes, I wanted to share with you the work or the progress that I have been done for my thesis, right? MBA thesis. So basically the beginning or the first part is I want to touch base and to mention that this is exactly what we did last time or the same thing, working with the bibliometrics library in Jupyter in R. It's parallel to working with biblioshiny. So basically what we are doing here is stuff, at least in the beginning, right? It's stuff that it's can be done through biblioshiny and also in parallel, if you want to get more power or to have more control on the analysis that you do, you can do it also programmatically using the APIs that bibliometrics gives you. So this is just to share the background. We load the content from the databases that we downloaded according to what you taught us, Munim. So this is standard methodology. The important stuff is that you need to have a database with the documents, with the articles that you want to analyze. Yeah, so this is the baseline. This is what we need to have in order to do basically anything. So this is a standard. This code is basically, so this part is not related to the text mining, but can help us. And I talked about a little about in our previous video. I do some filtering. I try to get articles that has a good index, which 0.77 basically correlates with the Q1 publishers. So basically, I have two databases or two data frames. One is the original one, the merged one, with the content from Scopus and Web of Science. And I have another one, which is smaller, and it contains only the articles that were published in a magazine or in a publisher which has more than 0.7 rate, which is more or less Q1. So these are, in J, I do have the articles belonging to the Q1 publishers. So this is, again, not related to topic modeling or to text mining, but it's the baseline that I use for the analysis. So basically what I'm trying to do is to help myself to write the thesis, right? So I want to see what do I have inside the articles. I need to understand, I want to understand. I'm aware that I will need to read, I'm reading, I already started, I'm in the middle of reading a huge amount of articles and I need to understand and basically everything that the systematic review, literature review mandates, it's still relevant. Whatever we do in this branch of science, we still need to do it. But I want to help myself a little and try to see if I can have not shortcuts, but some kind of a little help or guidance from any other automatic tool that I can have. So basically, what I try to see is what do I have inside the articles, which I'm reading and which I need to read, but I would like some support on understanding what's going on in those articles. So first, and in order to make sure that we see what we already have without trying to complement it. So we do have the bibliometrics or biblioshiny methodology, which uses a statistical tool, MCA. And last time I think we discussed, and the examples that they give you is that they use the references field and based on the the keywords field.
Keyword. Yeah,
And
yeah,
sorry. So based on the keywords field, you can see which are the keywords and what is the MCA. Again, I don't have enough statistical knowledge in order to understand, but I do know which is trying to do some dimensional reduction. And here, if you have valuable information about the dimensions, and I mean, it's important. But I said, okay, so I do have the keywords, and it's good knowledge, and this is something that can help me. But I also have the abstract inside the database. I mean, for each document, I don't have the whole documentation, the whole PDF or the whole article, but I do have pretty much, I would say, a summary, or many of the words or the relevant or the important words are also should be also in the abstract. So let's
yeah,
see what we can get, right? So let's see what we can get from the abstract. So basically, so first, uh, just to show how do you get it, because when you work with R directly, you do have the information. So this is the data frame. I can see the keywords. I can see the abstract for all the documents that I have in the data frame that I created above, right? What I showed you, that I take
yeah,
the documents. Okay, so I do have the abstract here. So let's see what we can do. So first, we can also do the MCA method, the MCA analysis with the abstract. I don't think that you can see a lot of. I mean, many of the words
yeah,
are so many that basically you can't get any valuable. At least for myself, maybe someone else with more statistical knowledge can get more value from here. So I started to do some short research, and I tried to understand. Okay, so these are the statistics methods that I have. And I also understood that we do have co-word analysis, or which is also a valid methodology for trying to understand. So we can do co-occurrences of the keywords. It's also something that can give you some understanding of what we have in the articles inside. But I say, okay, so and this is what I put also my background for what I do in my full-time job. I work with big data, and I work with Hadoop and Apache Spark, and say, so okay, so how do we do this kind of stuff when we work on with big data? And I was trying to look what are the algorithms that we use. So honestly, I went to the gray literature because this is basically what I do on my day to day. So what I saw is that for this kind of work, what we do in the, I would say, in the big data world, or in when we work with the large amounts of information, is that we do topic modeling, which is a text mining statistical, also statistical tool. And when we do top modeling, we particularly, or more specifically, we use the latent Dirichlet or Dirichlet.
Driglet, yeah,
Yeah, so it will take me a lot of more time to pronounce it properly, but
yeah, no,
LDA. Okay,
yeah,
so basically what we do, what the libraries or the algorithms that we apply when working with Apache or Spark is LDA. This is topic modeling, classical, the most popular, the most, um, I would say, the most used algorithm in the industry for this kind of
yeah.
analysis, text mining, right?
Mhm.
So I say, okay, so I do have it. I basically have everything. I have R, I have the information. Basically, we will talk a little about if the abstract of the article is enough.
Yeah,
But basically, we have the text. I have the background, the R background. So let's see how we merge and how we do topic modeling with the information that I have. So first, again, this is a background. This is bibliographic coupling, classical bibliometrics. So no need to expand about that. But this is the baseline that I have.
Yeah.
From here, I can start the topic modeling analysis. These are the libraries that you need to import. They are all well documented, and you can download it. It's open source, so it's available for everyone. And this is where we start to work. So another very few words about the access to the raw data. And this is important because when we have access to the objects that BiblioShiny exposes to us, but doesn't give you the direct access. Once you get the access, you can do a lot of things. So basically what I did here is getting the list of articles based on the cluster that it's shown here in the graph. Okay.
That's very nice, yeah.
Yeah, and also if I myself want to go to the article and read it, so I know that I know how to go to the Excel, search for this article. I know it belongs to cluster 1 and all the other clusters. So this is also helping me regardless of topic modeling, and help you also in doing in planning your research, how to read the articles based on the clusters that you get from the graph. Another thing that you can get in the same way is the degree of the graph. So, so if you see here, for example, you see that this article from Bennett is the one having the bigger or the biggest degree in the graph, right?
This is very nice, actually. This will help us a lot. A lot of the time, you know, if we have 50 articles in a cluster, and theoretically all the 50 are supposed to have the same theme or same topic, right? But then maybe we don't want to review all of the 50. We maybe want to review only the 10 or 20, something like that. Then one of the best way of selecting those 10 would be to look into the degree, right? Yeah, but I don't know, you might have some other thoughts about the degree as well. Yeah, so if you have some, yeah.
Yeah, so I did that. So I checked this article specifically. It's very interesting why or how this article has the highest degree. I mean, it's citing together with new other documents. I'm giving your explanation. Forgive me for that because you're here, but I'm quoting basically the explanation that you gave about bibliographic coupling. So it's interesting when you go to the document itself, to the article. It's very interesting to see which are the other document articles and what are they citing together.
Yeah.
So it helps you on that. Basically this raw data, and also this raw data is what allows you to keep going or the topic modeling analysis itself. But regardless of that, it's also I think it's also helpful. So let's go to the topic modeling, and basically this is all the code that we need, and most of the code, it's, I would say, even trivial. So I don't know if it's good news or bad news. You don't need to have almost any knowledge. I mean, I'm oversimplifying it. I'm talking about myself as well, right? So for example, all these parameters like the alpha, when you start to read the LDA, they are relevant and important, and it's better to know. I don't, okay, but it's better to know what they represent. It's a lot of statistics and bias statistics that you need to understand. The more than you understand, of course, the better. But you don't need necessarily, and this is, I don't know if good or bad, but you don't necessarily need to understand everything in order to get good results or to understand what's coming up from the LDA. So the LDA gives you, it's a generative algorithm. So it means that it gives you new document based on the documents that you feed the engine. And as I said, you don't need to know a lot. You just need to know, for example, that you want to have stop words. So there are standard or really predefined stop words in English that you don't need to take care of. For example, yes, no, I mean, those are trivial ones, but there might be stop words relevant to your topic. For example, decentralized, in my case, appears on every article.
Yeah.
So it will basically give you a lot of noise to the model, so you need to remove it. Also, decentralized DeFi research, Elsevier, it was almost on every document because I downloaded, right? I
Yeah.
downloaded this from Scopus, so this word appeared every time. So paper, proposal. So these kind of words are not in the predefined English stop words list, but you need to add it yourself. I skipped one thing that we will discuss in a moment. You need, there are other important things that you need to be aware of. For example, we don't want words that are less than 3 characters.
Yeah, that's important actually. Yeah.
Almost goes without saying. This one is good. It's a good parameter that I'll talk for a moment. Other parameters that are important is the token the words team. So, for example, it's an algorithm for stemming the words in order to make the same like kind of root words. For example, financial and finance are considered the same word, and or plural and singular, and all this is being stemmed. And this one is important because this one gives you, if many times you want to have single word, but many other times you want to be able to analyze a pair of words.
Yeah.
Especially in our case, I wouldn't say most of the times, but a lot of the times we're talking about a couple of words that have a specific significance. So you want to consider doing the analysis or one n-gram or 2 grams or bigrams. So we check that. By the way, we can do both of them. So for example, in this case, smart contract appears as a smart contract, and smart and contract, they are also considered. So you can play with that. Here is the actual execution. There are some kind of know-how that you need to do because it's randomized. It's a randomized based algorithm, so you need to reset the random algorithm in the language, in the R language. So basically, this is all the pre-analysis or the pre-work or the preparation of the data that you need to do securing. And one very important algorithm, so a few words about the LDA. The LDA, it's like similar to the key clustering, or I would say parallel to the key clustering, because it is unsupervised. So it will try to find, or it will find you the hidden topics inside the corpus of the documents without any hint. So it will use bias statistics to check, but you do need to define how many, let's say, clusters you want the algorithm, or topics you want the algorithm on. So you need to play with that. If it's 3, 4, 2, maybe, how many topics you want the algorithm to try to find for you. So originally I start with 3. I gave all the abstracts to the algorithm, and this is the game's out. And you need to try to understand what you see, if it helps you or not. Maybe you want to play and see 4 topics, but basically after I did some kind of, I did play with it, what I see is that it finds basically 3 topics. One is related to financial, to the technology of the financials, and maybe the risks and the regulation that we need to apply. I mean, these articles are related to decentralized finance. So it makes sense and I saw it in the articles, that many of the articles are trying to understand what is this technology leading to, how do we regulate it from the government because of the risks that it can have. So this topic might be indicating this group of articles. The second one is more related to the technology of Ethereum, which is a smart contract blockchain, and it is more technical, and it's more about the technology itself. And I also saw this on the documents and the smart contracts, and all this technology based on Ethereum looks pretty much about this group. The last one is more financial. It's more about the market, the assets, the cryptocurrency, and the volatility, NFT, investors, spillover, which are financial topics. And it's more related to financial. So this is what the outcome that you can see. By the way, once you have R and Jupyter, you can play with the graphs, and it can give you a lot of good stuff for your writing itself. I mean, it looks, you can get very nice pictures to show in the presentation. So this is the
looks very
same that
nice, yeah.
looks good, right? So
yeah.
So this is the same list, but also what the LDA gives you is also a statistic value or score to the relevance of each word inside each topic. So you can see, for example, when I say risk is not as important as technology or financial. So it's also important to get this, see the relation.
Really, yeah, from here, we looking at the first couple of words here, we can already get an idea. So as you say, the first one is more towards finance, traditional
technology.
finance, yeah. Then the second one is more about contracts and transaction and a smart contract. The third one is more about the market volatility, right? So the market comes up in the first. So we can kind of actually looking at it, we can get a very good idea that, yeah, these three themes are going on there. Yeah.
And I remember you asked very good question in my opinion, which is, can you play? I mean, can you take, for example, the cluster that was defined, let's say, in the bibliographic here, for example, in the bibliographic coupling. So I do have the clusters I showed before that you can see which each article belonging to each. So you can join. I mean, join is the actual syntax word. You can play with it, and you can, example, say, okay, let's not use the whole database. Let's use or the database that I downloaded, but let's see which cluster specific. So I join between the data frames, one containing the original documents, the second one is the outcome from this data frame that it's coming from the graph itself. So I join between both of them by the document name, and I say, okay, give me only document number one.
Okay.
So let's see what happens. So this is only analyzing the cluster one that basically we get from here. Sorry, we need. Let's see the degree. Let's see that. So we are talking only about these documents, which I don't know if it's.
I think it's the red one.
The red one, right? Okay, so we are talking only doing the LDA on this cluster of and this is what you see. So again, you need to try to understand. And here I see something new. Vote. What does it mean? What this is vote? What are we? I mean, maybe there's some. So maybe I need to reduce the number of topics to find because it's too much. So maybe there aren't inside the same cluster. Maybe we have fewer topics. So for example, again, vote right, governance, this is, here we have a new word that I didn't see before. What does it mean? Maybe we need to go back and define our original keywords database search, right? Maybe we need to go to maybe we need to go back to the query that we did on Scopus on Wheel of Science and try to expand the query, because maybe we have new keywords that we didn't see before. I didn't see before. Wash, what is this word going to say? Maybe we want to do a bigram and not a single. Tokens bolt right, wash trade. These are more than hints that you need to understand this database, what is distributed applications. And okay, so
This
we
is
have
interesting.
here, yeah. So this is the bigram and single gram difference. And another thing that again, bolt right and wash trade are important keywords here. So
Yeah.
you might want to see what's going on inside that cluster. What are that cluster talking about?
Yeah. This is
And
interesting.
another thing that the LDA gives you, it's not only the relevance of the words, but also the relevance of the topics. So, sorry, not the topics, the documents, the articles. So for example, this article, it's pretty much, we can be pretty much sure that it belongs to topic number 1 with a lot of security. This one, on the other hand, it's number 5, though, but it's
score is
far
very
away
low
from the first one. So you might want to consider that as well. Maybe this document and the first 4 documents are interesting, the next ones not so much. You need to see this information. But the point here is that you see that not only the words are relevant, also the articles get relevance from the LDA. So this this is for the dessert. You can also play with the word count. Okay. Also for the let me see. So let's see that. Let's make a word cloud for topic number 2, and maybe second version word cloud for topic number 2. Maybe you want to go off your document itself or your writing and show it in a nice way. Other topics, I find it. So this is what I did with the LDA, the topic modeling. And now I think I'm more ready, I would say, to go to the articles themselves and read them and see. And I have like a semantic map in my head.
Yeah.
Topics and what these documents might be talking on, and I have a better organization when I approach the articles themselves. And basically, this is what I wanted to show you.
Thank you so much for this, Benji. It's very interesting, and I think this is very useful. Especially, sometimes it might happen that we have really large number of articles. Yeah, and then so bibliometric analysis can be done in many different ways. Sometimes we go very deep into the articles, but there are studies sometimes, which are more broader when you're dealing with thousands of articles where you don't go into each of the articles in deep, but you give an overview of the field or the topic, So those kind of articles also, in those kind of articles, this kind of analysis could be really beneficial. Yeah. I have one question for you, that is, so if someone wants to, let's say, do this kind of analysis on some text, those are not article. Let's say they have some text from some interviews they have done. Okay, they have transcribed the interviews. They have some Word files with the text. Or sometimes people want to analyze some policy documents or things like that, which are not from any databases, but which is some PDF articles or PDF reports and things like that. So those can be still analyzed using the same approach, right? But we have to do
Yes,
something to load the PDFs, I guess.
absolutely. So that's a very good point, and I think that I wanted to talk about this in the beginning. Maybe the abstract is not enough. I
Yeah.
mean, it's not a large corpus, and maybe we need to do the analysis of the PDF itself. Absolutely, you can do. I mean, it's the other way. The examples that are available are doing what you are asking. I needed in order to I needed to do the work
To
in order to
make it to the
convert.
articles.
Yeah, yeah, because if you go to the internet and you see
Yeah.
the examples that they're using for topic modeling, they are using the U.S. Congress speeches of the politicians, so they
Uh-huh.
are analyzing based on the party that they belong to, and
Yeah.
and yeah, so absolutely, I did the other way. I took the abstracts from
Yeah.
inside the data frame, and I needed to fade, and this is basically what I did here. I mean, and it took me a while to understand the
Yeah.
know-how, what you need to prepare it. But absolutely, it's the other
Yeah.
way that it's being done. And this is uh, one of the things, one of the action items that I have is once I have the PDFs, the whole
Mhm.
list of articles in my laptop, in my directory or in my folder.
Yeah.
So feed it in the standard way and to see what's coming out from the whole list of
Yeah.
PDFs. Yes, absolutely.
That sounds good. Basically, so I haven't looked the codes in the internet yet. So I think basically we just have to change one code, right? Just the loading of the data. Everything is more or less the same as you are doing, right? Yeah. So just the loading of the data. Yeah. But okay, that's good to know that there are lots of resources on this. But yeah, thank you so much, Benji. Yeah.
Pleasure.
And I look forward to the full paper.
Okay. Working on that.